Uh, so we are going to be working on our lesson 17, the area of a circle today. We are going to be working on this particularly. I'm going to make a video for the entire lesson, so that means you're just going to be watching, following along. If you have any questions, you can reach out to me through email or through the Teams program. I will happily try to set up a small tutoring session if we need to during the day to help anybody who does not understand the lesson. So, yeah, let's just go ahead and dive on in and we'll get ourselves moving along here. Should only take us about 15 to 20 minutes to run through the lesson. So, this should be a good short video. Trying to make sure I get a nice little, look here because, wee, hi. All right. So for exercises, so I'm on lesson 17, the area of a circle. In my book, it is page S102. It means it's going to be a little bit further along in your book. But again, mine is roughly S102. All right. So problem number 1 says solve the problem below individually. Explain your solution. So it says find the radius of a circle if its circumference is 37.68 inches. Use pi approximately 3.14. Okay, so if you remember, we have the formula for circumference is 2 pi r, or the circumference is pi times diameter. Okay. Now, they've already told us that we're going to be using pi, which is 3.14, and it's already told us that the circumference is 37.68 inches. All right. Now, we need to figure out which one of these we're going to be using in our solution. Well, it says in the beginning of the problem, find the radius. So I'm going to use this one right here, 2 pi r. Okay. So I'm going to write it over here. Circumference equals 2 times pi times r. Now, I do not know the radius, so this is my unknown. I know everything else in the problem, so now I can substitute. The circumference will be c, and then, of course, for pi, we're going to use 3.14. All right, so the circumference is 37.68 inches equals 2 times 3.14 times r. Now, we've talked about this before. In order to solve for a variable, we have to use the inverse operations that are being used in the problem. Now, this is 2 times 3.14 times r. So the inverse of multiplication will be division. So we're going to divide both sides by 2 and 3.14. Okay, so 2 times 3.14. So now we have 2 divided by 2 is 1. 3.14 divided by 3.14 is 1. So we get left with r equals. Now we need to use our handy dandy trusty calculator. All right, so let's put this over here. I want to make sure we can all see it. All right, so we got 37.68, okay, divided by, okay, and I'm going to put a nice little parentheses right here, 2 times 3.14, and then close parentheses. All right, and we get 6. All right, so the radius is 6, but 6 what? Got to go back and find our unit of measurement, which is inches. So our radius is 6 inches. Okay, that's how you solve the problem. Okay, this is when you're trying to find something in the problem other than what you're typically used to finding. Like if I had area equals length times width and I knew the area, okay, but I didn't know what the width was, okay, I would solve by dividing both sides by the L to get the width. All right, this is re-engineering a formula to solve for an unknown. Not really all that difficult, okay? All right, so let's take a look at number 2. Determine the area of the rectangle below. Name 2 ways that can be used to find the area of the rectangle. All right, now, when I was in school, okay, and this was just when I was in school, the one way I was always taught that was area equals length, okay, length times width, okay. I could solve area by taking the width and multiplying it by the length, okay. That was how I was taught. That was the only way it was taught to me when I was in school. Now, the other way, though, and this is something that I probably would have done if I was in your shoes, okay? You can count, okay? You can count the squares inside the shape. Okay, because these are all little squares that make up the shape. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and 24. So that's what the area is. And this is if we use the second method. If we use the second method, we get 24 square units. Or in this case here, we get 24 square centimeters, because that is our units. 24 square centimeters. And like I said, when I was in school, it was just area equals length times width. Okay, so area equals length times width. So area equals 6 centimeters times 4 centimeters. Area equals 6 times 4 is 24. Centimeter times centimeters would be centimeters squared. Okay, that's how I found out. That's the way I was taught when I was in school, was number 1. All right. Now let's move on to question number 3. Find the length of a rectangle if the area is 24 centimeters squared and the width is 3 centimeters. Oh, look at there. This is exactly what I was saying about up at the top. We know the formula is area equals length, okay, times width. So we need to know the length and the width in order to find the area. Well, we were given the area and we were given the width. So what is it that we need to find? Right, we need to find the length of the rectangle. So we substitute in what we know. The area is 27 centimeters squared. All right, we do not know the length, so that's our variable. We know our width to be 3. Okay, so we need to solve for L. The opposite of multiplication is division. All right, and make sure, see, even Mr. Hale forgot his units here. So we're going to divide by 3 centimeters. 3 divided by 3 is 1, so that leaves me length equals 27 divided by 3 is 9. Centimeters squared divided by centimeters is going to be centimeters. So my length is 9 centimeters. Okay? You will get better at doing this the more we practice. So I promise you, if you're struggling, if you don't understand how I'm filling in everything, like I said, ask questions, send me emails tomorrow, let me know what's going on, where you're misunderstanding, where the confusions are at, and we will sit down and we'll take some time and work some stuff out, okay? All right, let's continue on, okay? Let's see, I would much prefer us to do the exploratory challenge in class, so we're going to come back to that one, okay? We will continue on with example number 1 on page S104. Okay, so it says use the shaded square centimeter units to approximate the area of the circle. Okay, so let's see. It says we got to use the shaded ones, so that means we got to count. All right, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79. So 1/4 of the circle, okay, is 79 square units. Okay, Mr. Hale, why'd you say 1/4 of the circle? Well, look, only 1/4 of the circle shaded. The area is not going to be just 1/4 of the circle. The area is every square inside the circle. So we can't say 79 square units is my area, because that doesn't make up the whole circle. So instead, I got to take 79 and multiply it by 4. Because you remember, 1/4 is 4 parts of one whole. Okay, so we got to multiply by 4. 9 times 4 is 36, carry the 3. 7 times 4 is 28. 28 plus 1 is 31. So it's 316 square units is our estimate. Okay, so now we got to figure out what we're looking at. Okay, now obviously I'm not trying to find the area yet. This was just an estimate based on the question. So this is just an estimation. I'm assuming that it is 316 square units. All right. Now, it says, the next question says, what is the radius of the circle? Now, remember, the radius is from the center of the circle, okay, all the way to the arc. So this would be our radius. So we got to count how many squares are in our radius. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our radius is 10 centimeters. Where are you getting centimeters from, Mr. Hale? Way up here. You see, it tells me that each little box is centimeters. So I'm making sure I put 10 centimeters down. So what would be a quicker method for determining the area of the circle other than counting all the squares in the entire circle? Oh, look at you. You guys are already jumping the gun on me here. Okay, we're going to use the formula. Area equals pi r squared. Wait a minute, that's the formula, Mr. Hale? Yes, that's the formula. I know it's got an exponent, and we're all scared of exponents. I get it. I understand. But I promise you, it's not that difficult. Okay? Just imagine it's just the area equaling the pi times the radius times the radius. That is all you're doing. Okay? I know it looks crazy. All right? I know it looks crazy, but we can do this. All right, so, all right, let's take a look. Using the diagram, how many squares were used to cover 1/4 of the circle? We said there were approximately 79 squares. Okay. Now, it says, what is the area of the entire circle? Okay, so, we sat there and we assumed, okay, we made an assumption based on the information we had that by counting the squares, we would say that the area is approximately 316 centimeters squared. But now we got to find out if that's true. So that means we got to use the formula. Area equals pi r squared. Okay? So that means I got to substitute some stuff in here. So we're going to clear all this out. Let's make sure I clear all this mess out because we don't need all this. Delete, clear. There we go. All right. So we're going to use the symbol for pi, okay? And see on my calculator, it's way down here near the 10, okay? You kind of can see it right there. It's that little teeny tiny symbol right there. So I got to use shift pi to get pi, all right? Times, now what was the radius? Right, it's 10 centimeters. So we're going to do 10 centimeters, and we got to hit that little square button right there. So this is pi r squared. 3.14 times 10 squared. So we hit equals, and we get, see, it's telling me 100 pi. That doesn't do me any good, does it? 100 pi does not do me any good. Okay? But what I do know is that pi would be approximately 3.141592653. Okay, I do know that. So we press enter, and we get approximately 314.16 square centimeters. So according to this, area equals 10 squared times pi. So area equals 314.16 centimeters squared. So which one is easier to do? Using the formula or counting up all those squares? Now, using the formula is going to be a little easier to do. But, I mean, look at our answers. We were pretty darn close, weren't we? I mean, we came up with 316 centimeters squared just by counting 1/4 of the squares. And the true answer was 314.16. I think that's pretty darn good. I think that's pretty awesome. So, but this shows you that right here, the area formula is going to be the faster method to sit there and calculate the area of a circle. All right, so let's continue on. Okay. All right, so let's take a look at example 2. All right. We're going to give ourselves a little bit more space here. So a sprinkler rotates in a circular pattern and sprays water over a distance of 12 feet. What is the area of the circular region covered by the sprinkler? Express your answer in the nearest square foot. Draw a diagram to assist you in solving the problem. All right, so I got a sprinkler. It's right about here. Okay, we're going to kind of draw a little sprinkler here. Okay. All right, so there's my little sprinkler. All right, it's going to sprinkle water, okay, all the way out here. All right, here's the circle edge right here. Now that represents from the sprinkler to the circle's edge, that's the radius. Okay, this is my radius, and this represents 12 feet. Okay, so I got my sprinkler. The sprinkler shoots out water. It stops at roughly here, and we could do. I'm going to do a very good job of drawing a circle here, but I'm going to draw an edge as much as possible here, so y'all can see what we're doing here. All right, so there's the edge of the circle, roughly. Okay, 12 feet away from the sprinkler. All right. Now, so what does the distance 12 feet represent in this problem? Well, it represents the radius. Okay. Now, the next question here is asking us what information is needed to solve the problem. Well, if we're going to use the formula area equals pi r squared, then we need to know what pi is going to equal. We need to know what the radius is going to equal. All right, those are the things that we're going to need. Now, the question says that we're going to express our answer to the nearest square foot. So that means we're probably, the most common thing that's going to happen is we're going to end up using the legitimate pi, okay, to solve for our answer. And we need to know the radius, which is 12, okay? So now I can substitute in a equals, the radius is 12, so 12 squared times pi. And I'm going to sit here and I'm going to try to figure something out because we got to figure out why in the world let's see if, because we got to figure out why in the world we're not getting the pi the way we need to get the pi. See, it keeps on telling me pi. There we go. All right, so we'll use that right there. All right, now we're going to multiply that by, okay, 12 squared. All right, so pi times 12 squared gives us 144 pi. Again, that doesn't do me any good because I need to know what pi equals, okay? So we're going to, for the time being, we're going to sit here and say pi is going to be 3.141592653, okay? And we're going to multiply that by 12 squared. Gives us approximately 452.37 feet. But remember what the problem says. You're going to round to the nearest square foot. So that means we look at the tens place. The tens place has a value less than 5. So that means everything behind the decimal goes bye-bye, and we just leave 452. So that's our answer. So our area equals 452 square feet, or feet squared. Okay? Now, let's take a look. I was really tempted. I was thinking about let's do 3, but I think we're going to skip 3 for the time being, because there is a lot of stuff in here, and I want to make sure we get to some very important details. All right? If we were in class, I'd have you working on 3 on your own. All right? So let's take a look at numbers, exercises 4, 5, and 6. Okay? So remember, first things we need to know is we always need to make sure we write down our formula. So we're working with area. It says because find the exact area, so that means we're going to be working with pi r squared again. Okay? So that means we're working with pi r squared. So we got a circle that has a radius 2 centimeters, so the radius equals 2 centimeters. All right, we're going to try to find the exact area of the circular region. All right, so that means we're going to be using a equals, and we're going to be using pi again times r squared. So area equals, r squared is going to be 2, so 2 squared times pi. Okay, so that's area equals 4 times pi. So 4 times pi equals, see if I can get that done. There we go. So area equals 12.57 Okay, 12.57, and it's centimeters squared. Now it says find the approximate area using 3.14 to approximate for pi. So we're still going to use the same formula. Area equals pi r squared. All right, we're still going to use 2 squared because that's the radius here was 2. So 2 squared times 3.14. All right, well, 2 squared is 4, so we got 4 times 3.14. Now, we don't need a calculator to do this. We can come over here to the side, 3.14 times 4. All right, 4 times 4, that's 16, carry the 1. 4 times 1 is 4, plus 1 is 5. And then 4 times 3 is 12. Okay, now, there are 2 places, 2 decimal places behind the decimal point here. So that means, okay, 2 places. We make sure we write that down so we don't forget. There has to be 2 places behind the decimal in our answer. That is important. However many places there are in our multiplication problem, there has to be the same number of places in our answer. So that's 1, 2. So our area is approximately, and I'm going to put the approximate symbol, you see how I'm using the little squigglies, is approximately 12.56 centimeters squared. You can see the difference when you do an approximation versus when you use the full-on area, full-on pi. You can see the difference here. Okay, that's a big deal. All right, those are big differences in the numbers. All right. Now, look at number 5. The circle has a radius of 7 centimeters. It says find the exact area of the circular region. Okay. Now, I can sit there and tell you to pause it and work on the problem in your own, but we all know that we're probably not going to pause it. So, but I'm still going to tell you, I think it's a good idea if you pause right here, work the problem out on your own, and then see if you get the same answer as Mr. Hale does. All right? So again, pause. All right, so if you had paused, then that means you should be right where we're at now. So the problem was area equals pi r squared. Okay, and I know that my radius is going to be 7 centimeters, and I'm using the exact area, so that means pi is going to represent pi again. So I got area equals r squared, so my radius was 7, so that's 7 squared times pi. So 7 squared is 49, so I should have 49 times pi. Now Mr. Hale has figured out his calculator. All right, we're going to do this. 49 times pi equals 49 pi, yes. But you see that little button right there? That means we can turn it into a decimal. So, boom! 153.93804. Well, I ain't going to do, we're not going to do, that far out. So, we're going to round to the nearest hundreds place. So, we look at the 8 and say, okay, that 8's big enough, so we're going to round the 3 up to a 4. So, 153.94. All right? So, the area equals 153.94 centimeters squared. All right? Ooh. Let me come down a little bit so everybody can see. 153.94 centimeters squared. All right. Now, that's it. Okay? We just worked on area of a circle. Now, what does that mean for you? Well, it means a few things. Okay? Ooh, my bad. My bad. Hold on. Hold on. There's a second part here. Mr. Hale didn't see this. Ha ha ha. Says find the approximate area using 22/7 to approximate pi. All right, so this is the fun one. Oh, dear goodness gracious, dear goodness gracious. All right, so we got area equals pi r squared again. All right, the radius is 7. All right, so this time pi is going to represent 22/7. Okay, so now we got area equals 7 squared times 22/7. Okay, so we get area equals 7 squared is 49 times 22/7. Now, we should know that when we work with multiplying fractions and whole numbers, we can rewrite a whole number as a fraction. So we get area equals, and I'm going to write it as 49/1 times 22/7. Now, if you know this, and if you notice, I keep on putting dots because I'm no longer using x's for multiplication. All right, we're using dot multiplication. Now, 49/1 times 22/7. Okay. Now, according to multiplying of fractions, what we can do is we can do multiply straight across and put them in the numerator. 49 times 22 over 7 times 1. Now, in this position, what we can do is we ask ourselves, is there a number that I can divide both the numerator and denominator by to simplify it? And there is. 49 and 7 can both be divided by 7. 7 divided by 7 is 1. 49 divided by 7 is 7. So I get 7 times 22 over 1 times 1. Well, we know 1 times 1 is just going to be 1, so we're done there. 7 times 22, though, would be 154. 154 centimeters squared. Well, that's interesting. This is precisely 154 centimeters. But our answer in part A was 153.94. Does that mean when we do an approximation, our answers are going to be just a little off? Yeah, that's exactly what's going to happen. When you use 22/7 or 3.14 for pi, you're not going to get an exact answer because you're going to be using an approximation. Those approximations are going to sit there and throw off the answers by tenths or hundredths places. All right, so it's not going to be the end of the world. That's why they're sitting there getting used to using both 22/7 or 3.14 and using pi. They want you to see a variety of different approximations of the same answer. It all changes. All right, but the correct solution will always be the one that uses pi as the correct answer. Even when we sit there and round off, we still mess it up. But if you write it down all the way out, that would be the correct answer. All right, so let's look at C. What is the circumference of this particular circle? So circumference equals 2 times pi times r. Okay, so this time we got our radius being 7 again. We're going to use pi being 22/7. Okay, so circumference equals 2 times 22/7 times 7. Okay, well, look at there. Those 7s can cancel out again. Leaves just me 2 times 22. Well, 2 times 22 is going to be 44, for that is 44 centimeters as the circumference. All right, and that will be the end of lesson 17. So let's go ahead and get our classwork into play. All right, let's see. I want you guys to do, okay, give me, all right, so we're going to do, let's do numbers 2, 3, 6, ooh, I like 8. All right, now I'll come back and do 5. So 2, 3, 5, 6, and 8. This will be your classwork for tomorrow, okay? This will need to be done before 11:59 p.m. on February the 23rd, okay? You will get a formative link for it, all right? So be prepared. I'll make sure to post the link up in both YouTube and in the email that I send you. Be prepared. I'm just going to send this email to my 2nd period, my 5th period, and my 6th period class. Okay? Those are the only classes that are going to get this video. All right? So be prepared for that. All right? With that being said, I appreciate you guys taking the time to watch the video. We will pick up class again. I will see you all probably on Monday of next week, depending on what happens the rest of this week. Just know that I miss you guys, and I will, like I said, I'm looking forward to seeing you guys back again soon. All right? All right, catch y'all later.